Hello everyone. Welcome to my YouTube channel on engineering mathematics. In this video, I am going to discuss a numerical technique named Gauss Seidel method. We will also see a couple of examples based on this method. So let us first see concept overview of this method. This method is a numerical iterative method to solve system of linear algebraic equations of these type. This is an example of linear algebraic equation in three variables x, y and z. Here, aii and bi's are constants. The Gauss Seidel method is a modification of the Gauss-Jacobi's method. So solution obtained using this method is a better approximate solution than Gauss-Jacobi's method. Also, this method takes less number of iterations than Jacobi's method. Now let us see assumptions to be made to use this method. The assumptions that we have to take are same as that of Gauss-Jacobi's method's assumption. That is, the given system of equation Ax is equal to b has a unique solution. The second assumption is the coefficient matrix A has no zeros on its main diagonal. That is, namely A11, A12, A33 and so on. These elements should not be zeros. They should be non-zero elements. And these coefficients should dominate the other coefficients in the equation. Note that if any of the diagonal entries are 0 or they do not dominate other coefficients, then we should interchange the rows or columns to obtain the coefficient matrix that has non-zero entries on the main diagonal. That means it should satisfy this second assumption. Now let us see steps involved in this method. In the very first step, we write the system in the following form. This is the given system in three equations in three variables. From first equation, we write x in terms of y and z like this. From second equation, we write y in terms of x and z. And from third equation, we write z in terms of x and y like this. We label these equations as equation number 1, 2 and 3. Now we proceed to step 2. In step 2, we assume the initial approximate solution to be 0, 0, 0. That is x is equal to 0, y is equal to 0 and z is equal to 0. Now in step 3, for the very first iteration, to find first better approximate value of x, say x1, we substitute y comma z is equal to 0 comma 0 in equation number 1. This is equation number 1. When we put y is equal to 0 and z is equal to 0 here, we get x1 as 1 by a11 into b1. Now this is updated value of x. This value and this value of z we will substitute in equation number 2, that is this, to get updated value of y, say y1. So we get y1 as 1 by a22 into b2 minus a21 into x1. Here z is 0, so this third term becomes 0. Now for the first better approximate value of z, say z1, we substitute updated values of x and y in equation number 3. This is equation number 3. Here we substitute x is equal to x1 and y is equal to y1 to get z is equal to z1. So z1 will be 1 by a33 into b3 minus a31 x1 minus a32 y1. So from step 3, we see that to find better approximate values of x, y and z, every time we substitute latest or updated values of the variables. Now in step 4, to find the second iteration, we substitute the updated values of x, y and z, that is x1, y1, z1 into equation numbers 1, 2 and 3 to get better approximate values of x, y and z, say x2, y2 and z2. So these are those equation numbers 1, 2 and 3. When we substitute updated values of y and z in equation number 1, we get x2 as 1 upon a11 into b1 minus a12 y1 minus a13 z1. Now for updated value of y, say y2, we substitute x is equal to x2 and z is equal to z1. So we get this as value of y2. Similarly for z2, we substitute x is equal to x2 and y is equal to y2 here. So z2 will be this. We continue this process until we get the desired accuracy in the solution. You can say that you get the desired accuracy if in 2 successive iterations, solution is matching up to 4 decimal places. Then we stop finding the next solution and we say that the solution obtained so far is correct up to 4 decimal places. I hope guys you understood these steps. Now we proceed for solving some real examples. In this first example, we are asked to solve this system using Gauss Seidel method. This is 3 equation system in 3 variables x, y and z. Let us take a look at this solution. As per step 1 of Gauss Seidel method, we have to write x in terms of y and z from first equation. We have to write y in terms of x and z from second equation, and we have to write z in terms of x and y from this third equation, like this. We label these equations as equation number 1, 2 and 3. After this, we proceed to step 2. In step 2, we have to make an assumption about the initial approximate solution, which is 0, 0, 0. After that, we substitute this solution in equation number 1 to get better approximate value of x, say x1. Then every time we use updated values of variables to find next better approximate values of x, y and z. We tabulate all these values in this table. This table has 4 columns, of which first one is iteration number. Second column heading is expression of x in terms of y and z. Third column heading is expression of y in terms of x and z. And fourth column heading is expression of z in terms of x and y. Iteration will start from 0. So in the beginning, we have assumed the initial solution is 0, 0, 0. We substitute this value of y and z over here to get updated value of x, say x1. So here after putting y and z 0, we get x as 17 upon 15, which is 1.13333. This is updated value of x. We substitute it over here, and for z we substitute 0. So we get y1 as 1.04888. This is updated value of y. For x we substitute this value, and for y we substitute this value in this equation to get z1. So we get z1 as 0.98459. Similarly, for x2, now we substitute this value of y and this value of z into this equation. So we get x2 as 0.99776. I hope guys you must have carried your calculator along with you so that you can simultaneously see the calculations. Now for finding next value of y, say y2, we substitute this value of x over here and this value of z over here. So we get y2 as 1.00132. Now this is y2 or updated value of y, and this is x2. Now we substitute these values of x and y into this equation to find out z2. So we see z2 is 0.99993. Next, to find out x3, we substitute this value of y and this value of z into this equation. So we get x3 as 0.99991. Similarly, over here, we substitute this value of x and this value of z to get y3 as 1.00002. Next, we substitute this value of x and this value of y in this equation to get z is equal to 1.00000. Continuing this process for next iteration, we saw these are the values of x4, y4 and z4. After this, I stopped finding further iterations because I saw that in these 2 successive iterations, solution is matching up to 4 decimal places. So now we can say that x is approximately equal to 1, y is approximately equal to 1, and z is also approximately equal to 1. So we say solution to the given system using Gauss Seidel method is 1, 1, 1. You can take a pause and try substituting these values of x, y, z into these equations and cross check whether these equations are getting satisfied or not. Please write me your answer in comment box. Now we go to example number 2. Once again, we are asked to solve this system of equation in 3 variables using Gauss Seidel method. Look at its solution. As per step 1, we have to write x in terms of y and z from this first equation. Then we have to write y in terms of x and z from second equation. And then we have to write z in terms of x and y from third equation. We label these new equations as equation numbers 1, 2 and 3. In step 2, we have to assume the initial approximate solution to be 0, 0, 0. Now we substitute this solution in equation number 1 to find better approximate value of x, say x1. And then every time we use the updated values of the variables to find next better approximate values. We tabulate all these answers as follows. So this is table of calculation. These are the iteration numbers. In the beginning, we have assumed solution to be 0, 0, 0. When we substitute y and z to be 0 and 0, we get x1 as 10 by 5, that is 2. Then we put this value of x and 0 for z in this equation to get y1. So we find y1 to be 2.5. Then we put this value of x and this value of y over here. So we get z1 as 1.9375. Next, we substitute this value of y and this value of z into this equation to find x2. So we find x2 to be 1.8875. For y2, we substitute this value of x and this value of z over here. So we get y2 as 2.07188. Now we substitute this value of x and this value of y over here to get z2 as 2.00508. Guys, by this time, I hope you understood how to substitute values of x, y and z to find out updated values for x, y and z. So these are those next values in iteration number 3 and 4. I stopped taking iterations after iteration number 4 because I see solutions in iteration number 3 and 4 are matching up to 2 decimal places. So after iteration number 4, we say solution to the given system of equation is approximately x is equal to 2, y is equal to 2 and z is equal to 2. For more accuracy, you can take more iterations in your solution. You can pause the video and try substituting these values of x, y, z into this equation and check whether these equations are getting satisfied or not. Now after this example number 2, I have a couple of examples for you. These are practice examples. You have to solve them on your own and write me in comment box whether you got these answers for them or not. In my next video, I will be coming with more such interesting topics. Till then, keep watching. Thank you all of you. Thank you for watching this video. Please subscribe my YouTube channel and press the bell icon to get updates about my new videos.